Right, these notes are all about electrons. So the Bohr model of the atom looks like this down here. This is hydrogen. And electrons move around the nucleus in these circular orbits. This is what Bohr said. And only certain orbits are allowed, and each orbit is a fixed distance from the nucleus. So an electron within that set has a quantized energy level. There were some problems with the Bohr model, though. His energy levels that he predicted only works for hydrogen. And now we've got PES data, photoelectroscopy, which we'll talk more about when y'all take AP, that there's subshells within in each shell. So now we've got the quantum mechanical model. So the quantum mechanical model says that electrons really don't follow orbits. It's more of a wave function. And these are the possible wave functions, okay? So what is really an orbital? It's just a graphic representation of the space an electron will occupy 90% of the time. And it's more of a concept than a physical structure. So this is what the first S sublevel shell, the 1s shell, could look like. This is where we find electrons 100% of the time. It kind of looks like a circle, though, don't you think? So within this circle, this is where we can find an electron about 90% of the time. So we say the 1s orbital looks like a sphere. And there's 4 different types. We have our s orbital, which looks like a sphere, the p, which kind of looks like a peanut, a d, which looks like a dumbbell. It's actually more kind of like this looking, and then the f, which is a flower. And so you have them on each axis, the x, y, and z axis. All right, so when we fill orbitals, they have to fill the lowest energy first, because nature always favors lower energy systems. So if you learn to read your periodic table, it fills in order, like you're reading a book from left to right. So this is the S block, then you've got the D block and the P block. And then helium is still in the 1s block, but he's moved over there. And then down here is your F block. So this big number right here, that's your principal quantum number. That's just whatever energy level it's in. So this is in period 1, the orbital type, so the S block, and how many electrons are in it. So this would be the electron configuration for hydrogen. Helium, first energy level, S block, 2 electrons. This would be lithium. And then sometimes we can write a noble gas shortcut. We can write the noble gas that comes before it in brackets, and that way you know it's full, because these can get pretty long. Beryllium, we always have to start with the 1s, so 1s2, 2s2. Boron, 1s2, 2s2, 2p1. So when you're doing this, you always have to start with hydrogen, and you read across until you hit whatever element you're looking for. So you always start over at 1s, and you just keep going. Okay, and then when you get to the D block, you'll notice it goes 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d1. 4s just has a lower energy level, so when you're reading it, you'll read off the periodic table. This is actually in order. Okay, the F block is also shoved down. Okay, so there's rules that y'all need to know. Each orbital can hold a maximum of 2 electrons. That's the Aufbau principle. And they'll spin in opposite directions. That's Hund's rule. One will spin up, the other will spin down. So for lithium, if you remember, our electron configuration for lithium is 1s2, 2s1. So we're going to fill the arrows. We have 2 electrons in the first block, so one goes up, one goes down. And then we have 1 in the second shell, and it spins up. It's always up, down, up, down. So for fluorine, our electron configuration is 1s2, 2s2, 2p5. So 1 up, 1 down, 1 up, 1 down. And then now for 2p, you want to go up, 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 because they don't want to be next to each other. Down, down. Nitrogen is 1s2, 2s2, 2p3. So they fill in order, one up, one down, up, up, up. Because electrons repel each other. They don't want to be next to each other if they don't have to be. So valence electrons, those are the ones responsible for reacting. So when you have ions, so if we have this electron configuration, this is your valence electrons. These are found in the outermost energy level. So if you have an ion, this is where it will gain it, or this is where it will lose it. So these are the inner core ones. That valence electrons are found on the outer shell. All right, here's your homework problems.